It's a couple days until my first vector calculus test. Well, it's not technically my first, because my first one was a take-home exam, and that was just all remedial information from Calc 3, and it was a take-home test, so there's not really much there. So this one is the first one that covers vector calculus specific stuff, even though luckily I've already seen like half of it. So while I haven't dipped my toes in those waters in a while, it's still reasonably familiar to me, which is leaps and bounds better than obviously looking at something for the first time, especially under the conditions that I'm doing them in, which is lecture, which is very light on examples and very heavy on theory and just getting into the weeds of things. But that's a whole other thing. So I thought I would do a video on how I'm preparing for this, and I'm preparing for it as I make the video, so a lot of these jump cuts will be me stopping the video and actually doing what I'm talking about. So the first thing I had to do, because I didn't know this information until today, 2 days before the exam, which is what was going to be on it. So I don't usually, for all of the previous videos I've made where I show how I prepare for stuff, I haven't talked about specific sections and topics, usually because people cover different things. But if you are working out of Marsden's vector calculus text, your first exam will probably cover at least some of this, if not most of it. So I figured I would include it in this video anyhow. Again, this is just for Marsden's text as far as the section numbers go, but obviously the topics are, the topics. So I got 3.3, which is extrema of real valued functions. 3.4, which is constrained optimization. 3.5 is the implicit function theorem. 5.5 covers triple integrals. 6.1 is the geometry of maps. And 6.2 for change of variables for integration. So that's what my exam covers. The first thing, which I've already done, because my professor basically said to just revert to homework problems, and the test would follow those pretty closely, and I want to believe him. So the first thing that I've done is gone through each one of these sections, and specifically the homework problems from those sections, and I wrote down the most common forms of questions. So for 3.3, which is extrema of real valued functions, aka things like the second derivative test, I have find critical points and determine if they're mins, maxes, or saddle points, verify that a point is a critical point, and determine if a point is a min, max, or saddle given different cases. For 3.4, which is constrained optimization, aka Lagrange multipliers, find min and max values of f subject to a constraint, and find the extrema of f given a constraint s. Basically, some of these are like reiterated, asking the same thing but in different words. But obviously, if you're not familiar with the wording of a question and you look at it and you're like, oh, I don't know what to do, then it's the same thing as you not knowing what's going on. So some of these say the same thing, but I felt like it was worth writing down, different forms. 3.5 is the implicit function theorem. So those kinds of questions are things like show a given equation is solvable for z near a point, discuss the solvability of a system near a certain region, determine if a map has a local inverse near a point, and when can a smooth inverse function be formed. 3.5 implicit function theorem is the first thing that I haven't seen before. And like I said, lecture leaves a lot to be desired, so I'm going to be spending a lot of time actually reading that chapter and probably referring to a lot of Patrick JMT and seeing if there's any in Stewart's, because I like Stewart's a lot more than Marsden for the overlapping content that they have. So I'm going to have to learn what all of these are to begin with. And then moving on to 5.5, which is triple integrals. I've seen that before. So we have questions like perform integration over a given box, match an integral with its region, describe the given region as an elementary region. I'm not sure what an elementary region is, so I'll have to go and check that. Find the volume of a region, evaluate an integral, and evaluate an integral given a function, and its bounding region. And then for 6.1, geometry of maps, I'm kind of iffy on this one. A lot of it seems very similar, but it seems more in-depth than what I remember. So that's going to be another thing I'm going to have to probably end up just learning from the beginning and going from there. Those questions are things like determine if functions are one-to-one and onto, find a linear map taking D star onto D, and find the image of a transformation. I know a lot of these look kind of similar to linear algebra and transformations, and I imagine the stuff that I'm not familiar with, a lot of these things are going to be answered, are going to play some role in like definitions and theorems and stuff like that, so I'm not super concerned. And then the last section is 6.2, change of variables. Those questions are things like find a substitution to simplify an integrand and find its Jacobian, evaluate an integral by making a change of variables, calculate an integral given a mapping, which I'm not sure that I'm very familiar with, and then calculate an integral given a function and its bounds. Again, same thing as just, reiterated. So that's those. Throughout this whole thing, I've been writing during class, and as I've been going through this tonight, I've been making a list of things to put on my cheat sheet because I'll have the ability to have a cheat sheet front and back of my own making, and it can have anything I want on it. So I want to make sure that I don't leave anything out, because I'm just going to kick myself forever if I have a cheat sheet and there's something that I really need on there and I forget to put it on there and I lose points because of it. So I want to make dang sure. So I have it sitting right here and I'm looking at it constantly. I'm adding things to it just to be sure, even if I'll probably add more stuff that I need, stuff that I know, like finding the magnitude of a vector, performing dot product and cross product and all of that stuff. But if I have the room, I'm definitely going to put stuff. I'm going to max out every square inch. But right now I want to put the equations, parametrics for planes and lines. I haven't done that stuff in a while. Jacobian stuff, obviously derivatives, trigonometric and otherwise, integrals, Cartesian to polar coordinates, Cartesian to cylindrical, and Cartesian to spherical. Cylindrical and spherical especially because there's a lot going on with those, especially with spherical. So at this point I'm going to go through these three sections that I'm not super comfortable with. The implicit function theorem, geometry of maps, and change of variables. And I'm going to basically just make notes for those. And once I do that, then I can cherry pick that or somehow try and amalgamate them and boil them down to, maybe 3 to 5 lines max each, because I have to make room for other sections as well. And some of these sections, like the second derivative test, has like 6 lines of just information for different things. And then I also have my old notes over here from Calc 3 for the stuff that I have done before, like Lagrange multipliers and second derivative test. What I'll probably end up taking from those is maybe an example, because if I just put the second derivative test on here, there's probably going to be some stupid thing that I do wrong or forget entirely and omit, and I'm going to hate myself for it. So what I'll end up doing is probably just putting my page, or at least one side of it, in 2 columns and having the section on one side and the, a good all-encompassing example for it on the other side, just to be sure that I'm applying things in the proper way and crossing my T's and dotting my I's and all that good stuff. And then once I get that figured out, I can make a rough draft for my cheat sheet, and then I can fine-tune that, maybe add some extra things if I find I have the room, like a unit circle, which is nice to refer to, because I could do it longhand and draw one and then figure out the 4 quadrants and the eighths and all of that other stuff, but that would take time that I don't want to waste, because I think you said I'm going to have like 2 questions from each section, and that's 6 sections, so that's 10 to 13 questions in an hour and 15 minutes, so 75 minutes total. I don't want to waste stuff on things if I don't have to, of course not. And then lastly, I want to make sure that my calculator can do the things that I think it can do, I'm pretty sure. So I get to use a calculator, and I can use whatever kind I want. It wasn't specified, and it's not a graphing calculator, so can't put that on me, Ricky Bobby. But this does derivatives. It does definite integrals and iterated ones, so second and third ones for, you know, line integrals and volume and all of that great stuff. And it does matrices, not that it really applies to this, but I like that it's there. And it's only 20 bucks. I did this, I covered, talked about this in my what's in my backpack update when I got this for engineering. Hashtag value. So I'll probably go through some examples just to make sure I know how to input the stuff properly, because again, I'm gonna hate myself if I can use a calculator for an integral and I put it in wrong. Because that would just be one of the stupidest things I could do. So once I get all of that done, like finally brushing up on the stuff that I don't know or haven't seen in a long time, not comfortable with, and my cheat sheet, then I probably won't look at my cheat sheet. I won't study from that for the extra day that I have, because I'm going to finish all of this probably tonight, or maybe a little bit bleed over into tomorrow morning. I'll probably study from notes and textbooks and maybe YouTube and doing some homework problems. But the cheat sheet, that's, you know, that'll be too boiled down. I don't want to relegate everything to the cheat sheet. I mean, obviously, like I said, I want to put as much as possible, but you know, I also want to understand this stuff as well as possible, and that's only going to come from the textbook, right? So I think that's more or less it. So hopefully you found it interesting or helpful, but otherwise, thanks for watching, and we'll see you next time.